Okay, so here's the deal with today is that I'm not going to sit here and review all this because I think it's something you can do on your own. But I'm going to briefly speak about a few things. Um, on this first page, I really think you can read through and remember all of these things. So I'm not going to go too heavily into explaining each one of these things because I think you can do that. On the symmetry, I think the only thing I'm going to add is remember if it's symmetric to the x-axis, it's not a function. The two big ones we talk about are even and odd functions, so you need to know what that means. Also remember that a property of even functions, that means if you put in negative x, it's going to be the same thing as what? So in other words, like f of negative 2 is the same as f of 2. So that is a statement that is true for even functions. Whereas odd functions, symmetric to the origin, means if you put in f of negative x, so like f of negative 2 is the same as what? Well, it's the opposite of f at 2. So I would know those relationships as well when it comes to symmetry and knowing which one is even and which one is odd. As far as slopes, lines, transformations, again, that's something that you can kind of commit to memory. I know that you know how to find slope, but believe it or not, we will be using the slope formula a lot. As far as the equation of a line, I know that if I say equation of a line, you think, oh, mx plus b. I'm going to be honest, this one right here is more your best friend. This is point slope. So it's just the reason why point slope is better is because you don't have to have a specific point like the y-intercept like you do for mx plus b. It can be any point on there. And again, I know that you know parallel lines have the same slopes, perpendicular lines, negative reciprocals. Increasing and decreasing, remember your hand is going up or your hand is going down. So as you move left to right like you read, my hand is going up in this section. Notice that these are x values when you're doing increasing and decreasing. Then my hand is going down and it's still going down. And then it's going up from 0 to here. And then it's going down. Notice the brackets on increasing and decreasing because you're talking increasing, decreasing over an interval. It doesn't make sense to talk about, is it increasing at 3? Well, that doesn't really make sense because you're talking about increasing over an interval there. And so I always use open brackets with increasing and decreasing. And then the last thing, oh, sorry. And then we have transformations. So remember all the transformations and remember vertical things are what you think. So if it's plus, it moves it up. Minus moves it down. Whereas the horizontal are kind of opposite to what you think. So if you remember, if you do f of x minus 2, that's actually moving it to the right 2. Okay. And so again, I hopefully you can remember those transformations. And I don't think there's anything there that you comes as a shock. And then we have the family of functions. Now these, again, are things that you have to commit to memory or have in your memory because there's so many, I mean, you're just expected to know them. And so I'll do one thing for you just to talk about what it is. Let's do a fun one here. I'll do the absolute value. So when you're doing the sketch, of course, that's just a little sketch of it. So remember the absolute value is the v there at 0, 0. So the domain, you can either put all reals or you can put negative infinity to infinity. Both of those things mean the same thing. So either one of those I would accept. For the range That's going to be 0 to infinity. I do like interval notation, so kind of do it there. What are roots? Remember, roots are x-intercepts or zeros, so it has a root at 0, 0. These two lines, of course, these two columns go together. Symmetric x and y are origin. So this one is symmetric to the y-axis. Therefore, if it's symmetric to the y-axis, then that means it's an even function. State if periodic, well, the only periodic ones are going to be the trig ones, so I guess you could put no or blank, whatever you want to put there. It is not periodic. Is it one-to-one? Remember, one-to-one means it passes not only the vertical line test, because it wouldn't be a function. These are all functions, so it's going to pass the vertical line test. But to be one-to-one, it would also have to pass the horizontal line test as well, and so this one is not one-to-one. So see if you can go through these functions, making sure that you remember what they look like. Watching your, if they have asymptotes, I would put that in. So these would be, of course, they're actually in the spiral on Schoology. It says pre-cal functions. You can find those. So if you're forgetting what they look like, you can go to that spiral in Schoology and look up these functions to fill out the rest of these guys. So again, you're just expected to know those. If I say picture 1 over x squared, you've got to be able to picture it. When we do area volume and it's like find the area under the curve 1 over x squared and you can't draw that, well, you're going to be at a very big disadvantage. So you have to be able to know these parent functions and know their shape, asymptotes, that sort of things off the top of your head. So you're expected to have that by memory. So that's what I want you to do this evening and get that in your little noggins. All right? Because in calculus, you have to remember all of algebra and all of algebra 2 and all of pre-cal. And that's what makes it so fun, is that you got to put all that stuff together. So get the stuff back in your head and we'll see you later.